Okay, so Filipe Fernandes is joining us from far away to give us data access tutorial, but I actually don't know where he's right now. So Filipe, you can share that with the group. And I just saw that you don't talk to a empty screen. I want to show you the group. We don't have a camera, but there are people here that going to listen to your tutorial. And Felipe has been involved in OceanHackWeek organization for many years, and he has helped with many of the tutorials and many of the events in the past. So we're happy to have him, even though remote. Felipe, you can take it from here, and I'll mute myself, and you can unmute.
Thank you, Valentina. Can you all hear me nice? Okay. Thank you for showing me the room. It is kind of odd to be, again, speaking to a screen, and I'm sorry I cannot be there. I really love OceanHackWeek, and I miss it. Ever since the pandemic and then other things happening in my life, I've never been able to attend one in person again. Maybe, who knows, next year. I also apologize. I'm not sure if I'm the only one speaking remotely to you. I know that this is super boring. I'll try to be brief and to the point. This tutorial is meant to be like an icebreaker. It's not really like a big tutorial with a lot of things for you to learn. We kind of touch base on visualization, on X-ray, and other technologies that are going to have more in-depth tutorial later on. But it's also meant to be a showroom of data that you can maybe use for your project. So pay attention to that. If you don't have a project yet, if you're still trying to figure out what you're going to do. So data access, we have servers everywhere, but not a bit to flip. This is a play on a very nice podcast, Beating Flips. If you Google that, you're going to find it. And I use XKCDs in all my presentations. I know that this just shows how big of a nerd I am, but I guess many of you are used to that by now. And this one is about how, even though we have our data in digital format, doesn't mean we are not immune to data degradation. In fact, we are very susceptible to it. For data loss on many different levels, from actually losing the data in a hard drive or having it degraded with something odd, or copying in a non-lawless way, or who knows, maybe even political ways. Right now, we're losing data because we're electing people, who doesn't agree with the data. All right, so who am I? This tutorial was taught by me, and last year was taught by Column, and then it's me again, but I kept him here because I'm gonna give him credit for all the edits and changes that he did to the slides. My name is Filipe Fernandes. You can find me online as OCFPAF. I know it's kind of cryptic, but I'm the only one with that. So if you find that, it's me. I'm a physical oceanographer by training, and I kind of got this title from other people. I've been in this field for 12 years now. I'm a data plumber, I'm a code janitor, and I'm a continuous integration babysitter. That's pretty much what I do for my day job. And if you have any question about that, get in touch on Slack, and I can give you more details on what I actually do for a living. But my day job is at IOS, the Integrated Ocean Observance System, which is broken down into all the regional associations that you see there. And more specifically, I'm hired by the Secura, the Southeast Coast Observing System, which may be more obvious as this tutorial progresses, because I'm going to use some of their data and examples. So big or small, we need data, right? And there are various sources of data out there, from a file that you put online, OpenDAP, that if you're a physical oceanographer, you probably heard of, AirDAP, which is kind of new, but not so much. I think it's considered old now. It's still new for me because I'm old-fashioned. Threads, which is a way of aggregating some services, usually OpenDAP. FTP, which thank God we are no longer using that much because it's super unsafe. S3 or any other sort of cloud bucket, and live access server, that if you know what that is, congratulations, you're as old as me. But it's very rare to find one of those these days. So before we progress, I was thinking about actually having a form for you to fill, but then you actually have an official OceanHackWeek form by the end of the OceanHackWeek. So I don't want you to have form burnout, but I do want some feedback on this tutorial. This tutorial had very little change since its first incarnation back in 2018, if I'm not mistaken. And I do think it needs to be renewed and refreshed. So if you have feedback for me for these slides, or if you think you can teach this next year, get in touch, and maybe you can actually be replacing me. So instead of being this voice from the beyond the internet, you can have someone in person there doing something newer and better than what you're about to see. All right, so what are the most common web services and type of services that we have? For in-situ data, like buoys, stations that usually collect time series at a point, we have the Open Geospatial Consortium standards called SOS, and the response is an XML file or a comma-separated file. If you have gridded data, like model outputs from all the ocean numerical models or weather models or satellite, the most common one is the OpenDAP, and the response is usually binary. If you have raster images, say, again, satellite images or similar, you have the Ocean Geospatial Consortium, again, WMS, way of sending you GeoTIFFs or PNGs. And then you have AirDAP, which is the new kid on the block, which has a RESTful API, which is great because we can interact with it many ways. And the response is your imagination. I usually make this joke, but really, AirDAP has so many different responses, make things so flexible that it's super, super easy to use. For images, there is also Stack, which used to be very popular at some time ago, but if you're not into geospatial sciences, you probably never heard of it. But if you are, you heard of it and you know about it better than I do. So I'm not going to touch that. All right, so what we're going to use in this tutorial, we're going to see AirDAP, it's probably the most important one from all of those that I presented. OpenDAP, kind of because there is still a lot of data behind OpenDAP servers. We're going to check one specific package that access some of these formats is called survey. I'm going to demonstrate WMS, and even though it's an old format, it's still very useful for creating apps and displaying your data for the public. And then we're trying to touch base on what CSW and CCAN are. Those two are kind of big catalogs that can aggregate data from various different sources. In the past, I used to do some CSW querying and getting data from, but that in itself is its own tutorial. So I highly recommend you to navigate to that link there. You do have this notebook or a version of this notebook because I'll probably update it after the tutorial. But if you navigate there, you're going to see plenty of examples, and you can try to play with that on your own. All right. Just before we start with AirDAP, and just a full disclaimer, because I'm going to say some things here that some people may not agree. I'm a big AI denialist. I don't think AI is helpful at all for us. Why? Mostly because the cost, the energy cost, the water cost, and everything that we are giving AI to have that response is not worth it. So if you have any doubt about any code here, please do not code and paste in a chatbot. Ask a human. We are coding for humans. We like human interactions. And I know talking about code and science with other humans, you can find someone with a big ego, and it can be problematic. It can put you down. But we have a code of conduct in OceanHackWeek, and you probably heard about it already, where we try to make this a safe space where humans can interact with humans and learn from humans. I'm not saying that AI is completely useless. It probably is, especially if you're like me, English is not your first language. I can get like a poorly written sentence that I usually do and ask it to make like a beautiful email that I can send someone. But one, that's not me. That's fake. And using a statistical language model to correct my English and justify a big data center somewhere and drain all the water that people could be drinking, I don't think that's worth it. I'm sorry, but you're going to suffer my bad English in my bad emails because I'm not going to do that. All right, so moving on. AirDAP, probably the most important one that we have. And our learning objectives are exploring your app server. We're going to use the Python interface. If you are an R programmer, there's also an awesome R package for it. If you're not a programmer at all, you can navigate to the server and create those URLs via form, which is super handy, because if you don't care about any of these, you can create a URL with the data and send it to someone, and someone can download it without any knowledge of any programming language. It's super easy to slice a time in a region of interest, and you can download in a format that you're familiar with. Remember when I said that LDAP responses are very, very flexible? Say you're still stuck with MATLAB, you can get a MATLAB file. If you want a comma-separated file to open on Excel, you can do that. If you want a JSON, because you're building an app that reads a JSON and gives you a beautiful web page with a visualization, you can do that as well. Really, there is so many formats that I can't even touch base in all of those. I can't even show off those here. Please go to their app documentation and check it out. So what it is, the flexible output, like I mentioned, for example, there's Google Earth as well, there is tab separated file. It can actually output OpenDAP as well, so it can be an OpenDAP server as well. There is a RESTful API, which we're gonna be using via the Python interface. It standardized dates and times in the results, which can be good or bad, depending where you're coming from. I usually think that this is great because it makes things much easier for you to deal with that kind of metadata, but it's also opinionated. So someone says, oh, I want a nanoseconds, or that doesn't do that. Oh, I'm sorry, yeah, you're gonna sacrifice somewhere. But it probably covers 99.99% of all the use cases. And there is a server-side searching and slicing. What does that mean? Sorry, am I going too fast? If I'm going too fast, please shout or jump all around or something, because I can't really see anything. So the server-side searching and slicing means that you're downloading less data. The server is going to do the searching for you inside your own computing time, and the same with the slicing. And when you actually request the data, you're going to download a small subset. And this is super handy if you're doing, for example, I want a time series from a numerical model that's huge, that like runs since the 2000s, right? I'm not going to download terabytes of data to get a time series for the past month. And with this, you don't have to. All right, so show me the code, right? Where is the code? We import the RDAP class. We feed it with our server. In this case, we're using the iUse glider server. And then we request a protocol, and we're requesting table DAP. There are two main protocols in RDAP, the table DAP, which has a table-like format, and the grid DAP, which has gridded-like formats. And that's it. Now we have an object to interact with the server and with all its table DAP data. So what services are available on this server? We can create a search URL. We're going to request a comma separator response because we're going to be reading that inside pandas, and we're going to search for all, right? You're going to see this a lot. At the end of the day, we're just creating URLs from the RESTful API. And we are usually requesting comma separated files so we can feed that in pandas, because panda data frames are easy to manipulate. And here with some pandas trick, I try to see what kind of services we have. We have more than 2,000 table data sets there. We have 0 grid DAP and 0 WMS. We could have those, but because this is mostly a glider server, we don't really have anything that's gridded or that's WMS. All right, so moving on. Let's query data sets that have the standard name seawater practical salinity. Standard name come from this Climate and Forecast Convention, so it's an easy way for you to find all the salinity using that standard name. And in air.py, we have this get category URL that can get you by some sort of categorization, right? So categorize by standard name. And now that I have all these standard names, I can check for this specific standard name. So let's see how many data sets we have that have seawater practical salinity. And it's about 1,000 of those. We just saw that we had about 2,000 glider data sets. and about half of them are using seawater practical salinity. I'm pretty sure that all those data sets have salinity. So what's happening here is that they probably use multiple standard names that refers to salinity. If you go into the CF convention, you can see that we have at least 4 or 5 names that refers to salinity. So that's one of the downsides of conventions that are kind of bloated. But you can have a smaller subset of that convention within your server, and your DApp does have that, and you're going to see that in a moment. All right, so let's narrow down our search. Let's do a search within a longitude and certain latitude and a certain time extent for seawater particle salinity. Just to show you what I'm going to do, I'm going to use here IPython Leaflet to create a map and plot a rectangle. And this is the rectangle that I'm creating, okay? And there you go. Sometimes I need to do this, yes. So this is the rectangle where I'm gonna do my search, right? Off the coast of the Northeast United States. And this is my query. So my query is within that bounding box, that geographical box. I'm gonna search between these dates, and I'm gonna search for seawater practical salinity. If you are running this notebook right now because you don't mind for the tutorial or you don't care for my voice, please change those queries and have something different than what I'm going to show, just for fun. And there you go. I'm doing a search URL. I'm reading that on Pandas, and I'm going to show all the data sets that we found within that query. So we found 19 data sets, right? So these are all glider names that are within that region, within that time, and have seawater practical salinity in their metadata. Let's get the first one, and let's create a URL to actually get the data. The missing parts to do that are the variables that I want to download. And here's what I meant by having a subset of standards that works within your server. And your DApp standardize, these are DApp server for glider, standardize the variables within these. Depth, latitude, longitude, salinity, temperature, and time. It's very simple. It's always going to be that. You're never going to have sal, salinity, salinities, or whatever. It's going to be this. Not all servers do that. Try to read about them and then try to figure it out. If not, try to see if they follow CF and leverage with CF in the same way I did in the previous search. I'm actually going to feed it the bounding box constraints, but I removed the time constraints. I want to get the whole data set. But in reality, the reason why I removed the time constraints is because I want to show you a cleaner download URL. And this is the download URL. And let's dissect it, because this is the URL that you can create if you go into the form. So breaking the URL down, we have the server, we have the protocol, which is labeled up, the dataset ID name. This is actually the glider and the date when the glider was deployed. I actually know this glider. It's blue. It's from SMAST, where I went for my PhD. Then the .html is the request, the format request. In this case, it's going to see the data in a page. And then the variables we requested, depth, latitude, longitude, salinity, etc. And then the constraints, like these are the data within a bounding box constraint. If I added the time, you're going to see the time here as well. As you can see, you can create this URL with pretty much any programming language that creates your valid URLs and check and download data. But it's a very nice RESTful API. Like, you can imagine that their DApp form is very intuitive. And I encourage you to just copying and pasting this in your browser and checking that form for yourself and try to recreate this URL using the form. Of course, we use a software to programmatically do these kind of searches, because getting 1 or 2 data sets via the form is fine, but getting 100, it's not. So here I'm going to reset my constraints by feeding it an empty dictionary. And I'm going to change the dataset ID. I'm not going to get that first glider that showed up in my query. The reason is because I think this particular glider here is more interesting. And hopefully that's going to become obvious soon. And now, instead of creating the download URL, I'm going to be using this function within IRDAPI that's just a convenience function, really, to create a appended data frame directly. There are other convenience functions to get your file, an etcdf response, and an X-ray object. But because glider data or table data, most and foremost, I'm just going to put in a data frame. I'm going to use pandas arguments to make the index column my time. I'm going to parse the dates. So these are actually recognized date times objects. And I'm going to drop any not a number in the rows. And this is it. This is my table with depth, position, salinity, and temperature, everything that I requested. As an exercise, try the 2x array method there and think why and where you should use one or the other. Spoiler, create the data. And let's do some data munging here. Using pandas, I'm gonna filter by all the data that's up 5 meters and up, right? Like the surface. And I'm gonna create a very simple line plot, which is a time series of the surface data where this glider was. Any oceanographer will very quickly see that from 35.5 to 37.5 is 2-point salinity difference. It's a lot for salinity, so interesting data. We don't know where this glider is from yet. And we are oceanographers, of course, so of course we're gonna do a TS diagram. And if you pass Oceanographer 101, you're going to see that we have two central water masses here. Very different one from the other, right? Beautiful. And then some massive things here that we have no idea what it is. So the plot thickens. Where is this glider from? And let's plot its position on a map to figure out. So we're going to do a zip map. We're going to plot all the latitudes and longitudes from this glider, and voila, this glider was one of the first across the Atlantic. It glided from the southeastern coast of Brazil all the way to Cape Town in Africa, crossing the Atlantic mid-ridge. So it has central water masses from both sides of the Atlantic. That's what we're seeing in the TS diagram. And that massive thing that we saw is probably when it crosses an eddy, or there are some very interesting eddies that comes here from Africa and comes into the Atlantic. And it probably crossed one of those. So it's a very interesting data set, very cool for a project if you want to do your project with this or other gliders that we have in this database. Like I said, URDAP has multiple responses, and you say, okay, I'm not a Python person, I need a matplotlib file. We have you covered, JSON or an SCDF compliant one, or just the header. And all these are links that you can click and see the response. Like this is the SCDF file header right there with all the metadata. You can see the number of observations. Let's see some information about this particular glider deployment, and maybe all the way here, yes. So you can see the people involved with this glider. You can see the vocabulary used, like the tables used. You can see the time coverage and a lot of information here. Do not dismiss metadata. If you're actually doing research, the metadata has the whole provenance of what you're doing. It's worth checking it out. For example, by checking the metadata, I saw that this glider is still processed with a MATLAB file. So somewhere down in its pipeline, it was processed with this I use glider flattened c.m, probably something that reads the raw glider file and creates an SCDF file. All right, I'm gonna pause here because I'm not sure if we're opening for questions or not, but feel free to interrupt me, like ask Valentina or Daria there, and they can repeat the question for me here. But feel free to interrupt me anytime if you have any questions. I know that's been a while since the pandemic, so people forgot how to interact on Zoom, but I'm here if you need anything. I'm not a voice from the beyond. All right. These exercises are not something that you have to do right now. You have this notebook, and you can do that on your own time later, but pretty much these are 3 servers that serve glider data. The IUS one, the OOI one, and the Voice of the Ocean one. If you're feeling adventures, you can use GliderPy, which is another library that wraps URDAPy and downloads glider exclusively from this server here. but it's a little bit easier and nicer to use. It's a little bit simpler and it has some plotting functionalities as well. So welcome you to try that. It should be on your hub as well. And you may find something interesting for you to work there. All right. The second most important one is OpenDAP. Can I have a show of hands now that I have the laptop showing all of you? Who here used ERDAP before? All right, just a few. And OpenDAP. No one uses it? Okay, one in the corner. Okay, two. Oh my God, I was afraid there for a moment. All right, so OpenDAP, it's probably still very common for satellite and model output. It stands for Open Source Project and Network Data Access Protocol. It's a mouthful, I know. It provides access to metadata via subsets in the web. It has a form, latest version has a form where you can actually do a subset similar to ERDAP. Similar, but not exactly the same. And many tools can read it because it's been out for a while, like NetCDF4, PyDAP, Xarray can read it directly, if I'm not mistaken, using one of those two backends. It's not hard to find a client for it. Most of the time, OpenDAP servers are behind a Threads aggregator or a Threads server, and having multiple OpenDAP endpoints. And there are software to explore Threads servers. One of those is called Siphon, which can give you some of this search functionalities that we have in ERDAP, right? And so our learning objectives, we are gonna open an Ocean model from a Threads service using OpenDAP and Xarray. We're gonna discuss the difference from an ERDAP request, and we're gonna plot it using the Xarray interface. All right, so I'm not gonna browse these Threads servers. I'm just gonna give you the final endpoint for this model. This is the Doppler model from Rutgers. And here I'm using a trick. If you never heard about it, Xarray, if you import CF Xarray before it, it will populate the data set with all the CF metadata that it can find. And now, instead of showing the data set, I'm showing the data set CF-fied, let's say. It's a little bit nicer to read and more metadata rich. Like I can see that this is an S-grid model. S-grid is the standard. I can see all the axes, and this is a bronze model because you have like so many axes because it's a staggered grid. We have the coordinates, and if you think the spatial staggered grid is confusing, check out the time coordinates. We have 4, because who needs one timeline when you can have 4? You see ocean models were doing the multiverse before Disney. Either my jokes are falling really, really flat, or I'm not getting any feedback from the video, but I'm a dad. I'm allowed to do dad jokes. All right, so we have the standard names, which we can use to leverage CF metadata to do high-level queries. And these are all the variables that we have in there. So moving on, I'm gonna get seawater potential temperature this time. I'm gonna get this particular date for no reason. And then I'm gonna get the surface. I mix things here on purpose. I'm using high-level CF name here. I'm using a high-level date here, and I'm using an index here because Xarray is that powerful. With the CF Xarray, I can use the CF name here. With the cell, I can use the high-level date, and with the iCell, I can use an index. You're gonna see more of Xarray, I believe, today, later on, but just bear in mind that Xarray is that powerful. I'm using 3 different high-level ways to slice data, just to make it simpler for me. Why I'm making this simpler? I don't want to know the variable name. I just use the convention. I don't want to convert this to an index. I want to use a proper string date. And I don't want to convert the non-dimensional vertical coordinate of the model to know where the surface is. I'm just getting the latest index where I know it's the surface. So you see, I'm being very lazy and using 3 different ways of slicing the data here just to get a very concise, like 3-line subset. And now we can plot the subset using Xarray.plot. Before that, I imported CartoPy, I created a projection, and I told it, please plot this property in long row and lat row, which are ROM's particular X and Y for properties. And this is a property, this is temperature, and voila, I have a map. You're probably going to see way better ways of creating maps in the visualization tutorial later on. Like I said, this tutorial is an icebreaker. You're going to see everything in depth later. I'm more focusing on showing you the data sources and how to get there. All right, the third one is survey. This is actually focused on a particular library than a service, but it started as an aggregator for the SOS services. SOS is slowly being phased out. So it kind of became an aggregator for certain data sets that used to be served as SOS. One of those is the co-ops data set, all the co-ops data sets. Survey is very interesting in how it slices because it went full open spatial by having a shapely object in any geometry. I'm actually using a square here, like I use a square for pi. But you can have here like a state boundary. You can have a natural reserve, an ocean natural reserve boundary, and actually cut your data exactly to that shape. And then we can query all the stations, the co-op stations within my region. I truncated here because there are plenty. And as you can see, we have all the stations. We have the National Oceanographic Service name, the National Weather Service name, its full name, the state, if it's active or not, and the kind of geometry for this station. What does that mean? It means like when it's a point, it's probably a buoy or some sort of device that's fixed somewhere. As you can see, it's all North Carolina, Georgia, South Carolina, and Florida. So these are all Sakura stations. And please modify this at your heart's desire and try to figure out more interesting ways of finding these stations. But once you find the station, and here I'm gonna single out one in particular, which is the Duck Station in North Carolina. And once you find all the information that you have about this station, you can actually instantiate a co-op station object, give it the name of the station, select the variable that you want, and have a very nice plot like this one. Here I'm using a trick of getting the today's date and minus 15 days. So I'm requesting the past 15 days, right, of data. And this is the past 15 water level from the duck station from co-op services, right? This is very powerful. This is very easy to use, very intuitive. And you can imagine, like, if you have a hurricane track and you have the shapely object for it, you can find all the stations along the path of that hurricane track and get data where the hurricane passed, right? Actually, there is an example of that in the iOS Code Lab, if you want to try that. Or if you're doing some sort of work for some marine reserve somewhere and you have the shapefile of that reserve and you're gonna know all the stations that are within that shapefile, you can do the same. Remember, and this is one thing that people usually forget when doing just kind of GIS operation. If you have a shapefile, like a line for hurricane track or for a marine reserve or something like that, use a buffer, because you may want stations that are nearby, but not exactly within your geometry. And I'm saying this because very recently I reviewed a work where someone had hurricane tracks and glider tracks, and they were trying to figure out where there's two overlaps to get glider data where the hurricane was. And they came up with very little data. And then I just said, you know what, use like a 20-meter buffer on your lines, and boom, the volume of data almost doubled. Because, 20-meter data, when we're talking about this kind of data, it's pretty much in there, like it's right where the hurricane, it's still within the eye of some hurricanes, right? Okay, moving on. We have WMS, the Web Map Services. This one is kind of old, and it's not really something where you obtain data per se, it's more to show data. And here we're going to use IPy leaflet to create a WMS layer within a map. And then we're going to create a slider that we're going to get all the data within these specific times. And for the specific date, within the slider, we can visualize data from next red. This was actually a date where a hurricane hit the West Coast. And this is our map. And this is our slider. And iPilotFlat is very powerful in a way that I can now move the slider to move the time and see the hurricane in full time, right? Let me move my map here, maybe, yeah. And there you go. If you move the slider back and forth, you can explore this data. So this is not really a way of obtaining data per se. It's more a way of visualizing data and displaying data. Depending on your field, what you're doing, you may see this as an end product for your research or for whatever you're doing. Last but not least, let's get into the catalog web services. And this is trying to answer this question. Is there a canonical source for all the data? Like, how can I find all these servers and endpoints that we're talking about? Well, I'm going to tell you. I don't know. And the reason why I don't know is it is messy. It is hard. I mean, kind of. I know a few places that aggregates all this. We do have the IU's CSW catalog that you can query, and you can see some examples of that. There is PangeoForge that also aggregates a lot of data. The scenario is changing very fast. People are creating their own data lakes, and they're putting everything in their own data lakes. But CSW is, in my opinion, one of the most powerful one. It is clunky, it is hard to use, but it's very powerful because you have a catalog web services and you can filter with what we call fast filters. And it's powerful because it can aggregate threads, SOS, or DAP, web accessible folders. It can be harvested constantly every day, usually nightly. It can then put them on the catalog and synchronize this catalog with multiple other catalogs. So if I query the IU's catalog for, let's say, salinity data in Glider, it will traverse all this, and it's going to probably show me that particular server that I used in my example. It's not something that you do all the time, but it's something that you do at least once to find where the data is. Once you find where the data is, you copy and paste that server or that endpoint into your script and you use the endpoint directly. Check out the examples in the IU's Code Lab. There are many other examples in there. I hope those are helpful for you. And I'm going to give you some more places to find data. There is the awesome AirDAP list, with there are many AirDAP servers in there. You can search across multiple AirDAP servers using this URL as well. AirDAP also have a multiple AirDAP search. It's kind of slow because it queries all those servers for you. Again, it's something that you do once, not all the time, but because once you find the server, you use that one. There is the environmental data service model viewer. So if you're looking for model data specifically, this one is great. And if you have a Fred server and you want to browse the server because it can be messy, many endpoints in there, you can use Siphon. Siphon is actually pretty good and pretty easy to use. We have some examples of Siphon as well in the IU's Code Lab. Some extras. How does this all work, right? Metadata, standards. So every time you collect some data and you do your due diligence of filling up with the proper metadata and with the proper standards, it makes it easier for us to use automated tools to find those data and to plot them, right? For example, you saw me using CF, climate and forecast standards, to find salinity within gliders, right? You saw me using the internal conventions of the IU's glider service to get the variable names and all that. So if we're following these standards, our life gets much, much easier. And this is just one good and one bad example of how to use or not to use those standards. Here I'm going to import like CF time, that's CDF time access, and the NetCDF4 data set to access this particular data set, which is an NetCDF file on the web. By the way, this file was removed, so this example doesn't run anymore. And this is part of the data rot that I tried to warn you at the beginning of my presentation. So data really goes away. The reason why this one went away, I have no idea. But this was the actual official example that they had in their official page. Like, get the data set, slice it, slice time, and then you need to know that minus 9999, it's bad data, so put nans in there, convert your time, mask your time for the time frame that you want to plot, and then you can create a plot, and then you have to plot with the mask and all these obscure slices. We need to use a dot because otherwise it's going to have lines connected all over the place. And then we have this image, right? There must be a better way, right? Yes, there is a better way. If we use X-ray, we can now slice temperature, and we can choose the first depth, and we can plot the 2008 year, and boom, dates are handled automatically for us thanks to standards. The X's are handled automatically for us thanks to standards, right? And the masks were handled automatically for us because X-ray knows how to handle masks, and all this information, all this metadata is within the data. So you see, we went from that complex multi-line example where you need to know things that nobody told you. You either need to read a manual about the data or dive into the data metadata. And now instead of that, by just using better software that leverages with good metadata, with just literally 3 lines, we create a better plot, okay? So that's what I had. I do have some extra notebooks, but because I'm remote and I know this is super boring to listen to this voice on speakers, I may leave those for you to check at your own time unless I am super early. Valentina, what do you think?
You have 10 minutes, 10 more minutes, Filipe.
Okay, let me see if in 10 minutes I can show you. Well, I'm actually not going to show you a full notebook, but I'm going to show you what else you have within that folder. So we have an example of gridded data set that you can play with. This is pretty much a review of ERDAPI, but for a gridded data set instead. You have combining multiple ERDAPs into a single query. This one was contributed by Callum. Are you still seeing my screen? Okay, not sure if you're seeing my screen or not, but I'm showing it anyway.
Yes.
Okay, so this one combined multiple ERDAPs to ask a nice question. Where are my glider and seals points within Antarctica? So you can actually find where they overlap, which is a pretty cool example. Check it out. There is one on sail drones, which are very cool instruments that can sail through a hurricane and collect some very interesting data. And I do have the server for that. And I also have a rant because they are removing data from it. So this tutorial was using this particular sail drone, which I believe was the first to cross a hurricane. It's no longer there, but we do have still some sail drones from last year. Then there is a notebook on cleaning up data, because if your data is not QA/QC, it doesn't matter how good your metadata is. And this one is very, very simple example on how to use Spartod to clean your data up. And last but not least is one on how to search ERDAP servers automatically. But this one is actually, I don't think it shows multiple ERDAP searches. No, it does not. For multiple ERDAP searches, you actually have to go into the manual. And all right, that's all I had. Any questions?
Any questions, especially if there's data sets that you may be looking for. Filipe may be able to tell you if they are on some of these servers. So.
I have a question, Felipe, for the example where you just had an HTTP URL and opened it with X-Array. Was that an ERDAP server, or was it really just a file location via HTTP?
It can be both. If the one that I had there that no longer working, I think it used to be an OpenDAP server. If it's just an HTTP file laying on a server somewhere, you have to use bytes range. So if you see on the URL in my example, like hash bytes, byte modes, then you can feed that into Xarray as well. However, I just found out that that's broken in the latest HDF5. So you probably have to downgrade your HDF5 for that to work properly.
Okay, thank you. That's cool.
Any other questions? Oh. Okay.